Well, hello and welcome to Math Blossoms. We're growing and mathematics is natural. I am the teacher, Miss G. And for today's math topic, we're going to talk about systems of equations, specifically how to solve them using the graphing method. There's a lot of information packed into this, so hopefully it will help you with your math work at school. Some of the information is related to some previous videos that I made on functions and writing linear equations and things like that. And I'll mention those once we get to it. So let's get started, won't we, by asking the question, what are systems of equations? And systems of equations are basically a system of linear equations is two or more linear equations that use the same variables. Now, we usually use x and y as the variables, but it doesn't have to be x and y. You can use a, b, c, d, or whatever. But whatever the variable is in the first equation, whatever those two variables are, they need to be the same in the second equation. So if you're using AB in the first equation, the second one needs to be AB as well. Now we're just going to use XY because that's what you see the most often. And so if you're looking at this equation here, y equals 1/2 x plus 3 and y equals 2x. That is a system because that is two separate equations. And the solution for a system of equations is the ordered pairs that both of the equations share. So if you look at the lines that are here, the first line here, if I had a point right here, let me get my pen so I can show you here. If I have a point right here, the blue point here that I'm drawing, that solution is just for this line that it's on. It's not for the second line, okay? Any point on a line is a solution to that linear equation. The only solution that both points share is this solution here, this red point that you can see. And that is the only point that they have in common. So that is the solution to the entire system of equations that you're seeing here. That point is 2, 4. Okay. Now, let's try some of these so you can kind of see how to do this. It says graph the equations to find the solution to the system. Actually, before I do this, there's one more thing I want to mention. If you ever want to check to see if the solution you get actually works with both equations, you can substitute that point in. Let me explain what I mean by that. This point that we found as our solution is x and y. So if I substitute this x and y in the first equation here, okay, that would be 4, because our y is 4, so we're going to just substitute this y with a 4, equals 1/2, and instead of times x, it's going to be times 2 because our x is 2, so we'll put that in parentheses to indicate multiplication, and then we add the 3. And we know when we're simplifying equations or solving equations, we often remember the order of operations, PEMDAS, and we know that multiply comes before add. So we're going to multiply the 1/2 times the 2. And 1/2 times the 2 is 1. And then when you add that 3 to that 1, you're going to get 4 equals 4. And so because 4 does equal 4, we consider that a true statement. And if it's a true statement, then that means that is a solution for that equation. Okay, let's try it with the second equation. The second equation is y equals 2x. So instead of y, we're going to use 4 again. And instead of 2 times x, we're going to do 2 times 2 because 2 is our x. And of course, 2 times 2 is 4. And we end up with another true statement. So this is one way you can check if you're ever wondering if you've gotten the right answer or not. You can plug those numbers back into both equations to see if you're correct. Okay, now let's try some. The first equations are y equals -1/2 x plus 3. If you are graphing this, now there is a video on this, how to graph linear equations. We begin at the b and we use the slope or the m to move. Okay, so begin at the B and then move with the M. So the B is always on the y-axis. We know this is the y-axis, and then this is the x-axis. So that B is called the y-intercept point, and it is on this y-axis. So we're going to start at +3, which is this little point right here. Now, since my slope is negative, I have a specific direction I have to move to get to that next point. So since we're moving with the M's, I tell my students sometimes to just go ahead and write, well, let me write this at the top because I don't want you guys to, I don't want it to cover up the next one. Okay, so if you're writing like a little help note at the top of your paper, you can say, hey, if the M is positive, if the slope is positive, then the movement is up with the top number and the bottom number goes right, towards the right. But if it's a negative slope, a negative M, then the top number changes from up to down. The bottom is still going towards the right, however. Like that. Okay, so let's go ahead and plot this down and right. So our slope is down 1 and right 2 since it's negative. So we're going to go down 1, right 2, make our second point from our beginning point at B. Down 1, right 2, make another point. And we just keep doing that until we run out of graph. Okay, I'm going to go ahead and connect these points and draw the line. And I would put an arrow on the other side, but sometimes you have to graph backwards. So until I know whether I need to graph backwards, I'm just going to hold off on putting an arrow there. All right, now the second equation, it's missing the x. So this is one of those rare circumstances where you're going to have a horizontal or a vertical line. Anytime you're missing one of the variables, either x or the y, you're going to be dealing with a horizontal or vertical line. Horizontal lines we call Hoy lines because they're horizontal, which starts with h, their slope is 0, and the equation starts with y. So we know this is a horizontal line because the equation is a y. So we just go to the y-axis, we find the 5, and we just draw a horizontal line through that axis. That's how you graph a horizontal line. Now, as you can see, the intersection point has not occurred between my 2 points. So because of that, I don't know what the solution is yet. So I am going to have to graph backwards. I'm going to switch colors to, let's just try orange, okay? Or this dark yellow color. Now, when you're graphing backwards, you basically take the forward graphing directions that you just did and you reverse both of them. So since I went down on the top the first time, I'm going to go up 1, and instead of going right, I'm going to go left 2. Okay, so now from the B, from the y-intercept point here, the 3, I'm going to go up 1, left 2, and make my point. Up 1, left 2, and I can do one more just so I can go through that line. And as you can see, there is an intersection point there. And that point is the point that both lines share, so that is our solution. And that point happens to be -4, 5. And another side note I would like to say is if you do have a Hoy line or a Vux line, which is the vertical lines, whatever they're telling you the y is equal to will be the y in your answer. So they're kind of giving you half of the answer right there. Okay, if it's a vertical line, you're going to see x equals a number, any number. I'll just put a 2 here just for an example. So if it is a vertical line going like this, we call those Vux lines, VUX. V stands for vertical, U stands for undefined, and X stands for the equation starts with X. You're going to find that on the x-axis though, not on the y-axis. You're going to draw a vertical line through that x-axis at the point 2. So if I was graphing that one, it would go right here. Whoops. Okay, I did that crooked. Erase that. There we go. Let's try that again. All right, so if I was graphing that, it would be through the 2 here, if I was graphing that vertical line. All right, now let's try another one. Now we have this, and they're both in slope-intercept form, so this ought to be easier to graph. Let's start with green here. Okay, so this will be my green one. Again, we're going to begin with the b. The b this time is -2, so I'm going to go down here at -2 on my y-axis. And then my slope is positive, 1/3, so that means I go up 1 and right 3. So let's go up 1, right 3, make a point, up 1, right 3, make another point. And that's all I can do before I run out of graphs. I'm just going to draw a little, draw my little line through these points. There we go. And now I can do the second equation. The second equation is y equals -1x. Remember, if there's no number in front of the variable is 1, right? So -1, if I turn that into a fraction, is -1/1. So whenever I'm moving, since it's negative, I'm going to go down 1 and right, there's my arrow, and right 1, okay? Because just like this up here. So we're going to start this time at the +2 instead of -2. +2 is right here. And we're going to go down 1, right 1, make another point, down 1, right 1, make another point, down 1, right 1, there's the point. And you can keep going as far as you want. I'm just going to stop right here and draw my little line going through there. All right, now I've got a solution, and my solution here is the 0.3, -1. Okay, we have one more to graph, and this one has one that's in standard form and one that's in slope-intercept form. If it's in standard form, you're going to need to convert it into slope-intercept form. There is a video on that. It's called Converting Standard Form to Slope-Intercept Form. It's under the Functions playlist on the Math Blossoms channel if you want a refresher on how to do that. I'm going to do it quickly, so this hopefully will be a quick reminder if you have had this experience before today. So I know that when I convert this one to slope-intercept form, I need to isolate the y. So I do need to get rid of this -6x, and I also need to get rid of this 2 so that y can be all alone, because in slope-intercept form, the y is all alone. So I'm going to need to move this over to the other side of the equation. And when I do that, the sign on the 6 will change from negative to positive. If the sign on the 6 was positive originally, it would change to negative. You just need to change the sign when you move it over that equal symbol. So when I rewrite this equation, I'm going to have 2y equals positive 6x. Okay, that's a 6. I know it looks like a B. And then -8. Okay, that's the first step. The second step is to divide by the coefficient of y. That will get rid of the 2, and it will become a 1y, which is what we want. And when we divide the 2 on the other side of the equation to make the equation balanced, you're separating it by terms. So the 6x divided by 2 becomes 3x. And the -8 divided by 2 becomes -4. So now we have our slope-intercept form equation. And so we can say that we can begin at this b, which is -4, way down here on our y-axis, and our slope is +3, which is really 3/1, which means I need to go up 3 and right 1. Okay, so up 1, 2, 3, right 1, make a point. Up 1, 2, 3, right 1, make a point. 1, 2, 3, right 1, make a point. I can go all the way up to the top right here. Okay, then I connect those, and I have my line. All right, now the second equation, we're beginning at this b, which is +6, and it's way up here that point there on the y-axis. And then our slope here is negative 2 over 1. So that means I need to go down 2 and right 1 since the slope is negative. So I'm going to go down 1, 2 squares, right 1, make a point, go down 2 squares, right 1, make a point, down 2 squares, right 1, make a point. I'll do one more. All right, now we connect the points, and as you can see, we do have our intersection point where both lines are sharing that point, and that point happens to be 2, 2. You can't see it, but it is 2, 2. If I erase this, you can see the point. Okay. All right. Now, before I move on, I do want to show you how to do these on Desmos, because this is, manually graphing. It works every time. If you're good at it, you can continue to do it. But some people have trouble doing these conversions and stuff like that. So if it's easier for you to use Desmos, I'll show you what that looks like. Let me move over the Desmos graphing calculator, and I'll just show you a couple of examples. Okay. So if you're trying to graph a line on Desmos, I'll just make up an example here. Y equals 1/2 x plus 3. Now, if you're trying to transfer this line onto a piece of graph paper, the best way to do it is to use your slope-intercept point, and you can scroll in and out. These are the scroll buttons right over here. And so if you wanted to count by ones, the axis lines, here's counting by ones. You can use your slope-intercept point, which is in this case 0, 3. You can just graph that point on your paper and then follow it up until you get to another exact point. Here's another exact point at 2, 4. All of these other points are fractional points. You don't want to do that because that's hard to find and put on your paper, right? So 2, 4 is another good point. And all you need are 2 points to graph the line. So if you just take your points, put them on your graph paper and connect them, you will have your line. So that's just a little trick if you wanted to try doing that on Desmos. Now, let's go to the next one, which is what would the solution be if the lines are parallel and never intersect? Okay, so that's a good question. When the system of equations are parallel lines, they will have the same slope m, but different y-intercepts, which is the b. Okay, the solution to a system of equations that are parallel is no solution. So if you think about it, here's an example of a parallel line situation where if you're looking at these two equations, it's really hard to tell if they have the same slope because one's in slope-intercept form, one is not, right? So if you convert this equation to slope-intercept form, the second one from standard form here, you will see that you will get y equals 2x plus 1. Now, as you can see, the slope in the first equation and the slope in the second equation is the same, but the y-intercepts for the equations are different. And it makes sense because this line is crossing at 1, this line is crossing at -3. But the reason the solution is no solution is because those lines never cross and they will never share any points. So remember, the solution to a system is all the points that both lines share at the same time. They're never going to share any points. So the solution is no solution. What does the graph look like when the solution to the system is infinite solutions? Or sometimes they say infinitely many solutions. Sometimes they say all real numbers. It just means, there's an unlimited amount of solutions because we know lines do go for infinity. Okay. When the system of equations are two lines right on top of each other, they will have the same slope and the same y-intercept. The solution to the system of equations that are the same line is infinite solutions. So the graph looks like there's only one line there, but there's actually two lines. I'm going to show you on Desmos how you can check that. So this one's in slope-intercept form because the y is isolated. This one is not, but if you converted this one into slope-intercept form, you would have the exact same equation as the first equation. y equals -1/2 plus 4. Okay, so if you're graphing both of these, you're just graphing a line on top of a line. And because the solution is the points that they share, they're going to have all of the same points and all of the same solutions, right? So, and they go for infinity. So they're going to have, an unlimited number of solutions that they share. So let's switch back to Desmos for just a moment before we do our review. And I want to show you a little bit about parallel and perpendicular, parallel and no solution, and also the infinite solution equations. So if I have this equation, y equals 1/3 x plus 2, and then I'll do another one here with the same slope, different b, 1/3 x plus 7. Okay, as you can see, if I scroll out, these are parallel. They're never going to cross, right? So that is going to be no solution. They don't share any points. Same slope, different y-intercepts, different b's. Now, if I have the same line, so let me put one in here like this. 4x minus y equals 2. And then I'll do another one here. That's -12x plus 3y equals -6. Now, as you can see, these equations look vastly different. They're both in standard form. You cannot tell if they have the same slope or the same y-intercept or anything, right? You've got to convert those to slope-intercept form to see if that's the case. Well, rather than do that, if you're using Desmos, you're graphing it. It looks like just one line. So that's a clue. If it just looks like one line, that it could be a line on top of a line. So the best thing to do to check for that is to click on this second equation here on this little squiggly thing. And when I do that, the blue line will go away. And if the red line is underneath it, it will still be there. So let's click on it. The red line is back because we erased the blue line. Now, if we click on it again, the blue line comes back, and you can just keep doing that to see, those are a line, those are infinite solutions. It's a line on top of a line. Okay. I think we are ready for review then. Yes. So great job, y'all. Remember that the solution of one linear equation is any point that falls on the line. Remember that the solution of a system of linear equations is any point that falls on both lines. If the point only falls on one of the lines, it will not be a solution to the system. Remember that if we do not have access to a graph, we can replace both variables x and y with possible solution point x, y to see if it makes a true statement when simplified. If you get the two equal numbers, it's a true statement, so the point would be a solution. That was what I did at the beginning when I substituted those values into both equations to see if they were solutions, and I got the 2 equal 4s. And remember that we can use the graphing method to find the point of intersection that both linear equations share, which is the solution. We can also use it to check to see if the lines are parallel, which is no solution, or if they are the same line, which is infinite solutions. Remember that having the ability to change an equation from standard form to slope-intercept form is necessary when graphing equations without the use of the Desmos graphing calculator. So hopefully this has helped you a little bit with graphing linear systems of equations. And the next video that you might want to look into is the one that I'm going to make on perpendicular lines for systems of equations. And also there are some algebraic methods on solving systems of equations that you can also use when you're not given a graph. And it's there's two different types of algebraic ways to solve systems of equations. So I'll probably have a video on both of those. So hopefully this helped you. And don't forget, growing in mathematics can be tough at first, but it does get easier with practice. So don't give up. And now it's time for me to say, it was lovely teaching you math today. Bye-bye.